All right, we're back here in the virtual classroom. I want to continue on a little bit with the idea that was presented in the previous video, where I had two carts. One had much more mass than the other one, and then I popped the spring between the two. The one goes flying off, and the other one moved ever so slowly. As I add more and more mass on it, of course, it moved even more slowly. Okay. What I want to do is to use that to demonstrate the fact that I can actually move the world, right? Most physics teachers can. Perhaps someday you will too. Okay, so let me get into the right frame of mind for this. This will take a second. You do realize this is a tough challenge. Okay, ready, set, hey-ya! All right, as my senses come back into, oh my gosh, I cracked it. As my mind comes back together here, I will put up a little calculation for you. I actually moved the Earth. I had momentum in this direction before I launched myself into this thing, right? And this thing is attached to this wall, which is attached to this building, which is attached to the Earth. So essentially, I ran into the Earth. Now, I'm massive, more massive than I should be, COVID-19. I have a certain amount of momentum in this direction, say 1 meter per second. All right, I launched, so the total momentum was therefore my mass times my speed. Let's say 100 kilograms, I wish. 100 kilograms and I'm moving 1 meter per second, right? That's the total momentum. Me plus the Earth, right? This is the Earth. The total momentum of the system, me plus the Earth. You have to consider the system whenever you approach any of these problems. Me plus the Earth. The total momentum is conserved. Total momentum, the Earth was not moving, right? I'm moving 1 meter per second. I'm moving this way 1 meter per second, 100 kilograms. So 100 kilogram meters per second. The Earth is not moving. Total momentum 100 in this direction. I bounced. Maybe I came off at a half a meter per second in this direction. Notice the direction has changed, by the way, so my momentum is now negative, right? So the total momentum must be in that direction. Afterwards, I bounced in that direction. What must the Earth have done? Quick answer, the Earth moved that way. Okay? You want to do the calculation, feel free. 100, the mass of the Earth, by the way, is 10 to the 24 kilograms. The speed with which the Earth is moving is something like 10 to the minus 20 meters per second, and you're not going to have any way to measure that. Okay? I'll give you an easier way to do this so you don't hurt yourselves. You can wow mom and dad. At dinner time, take your keys. Okay? Again, same thing. Me and the keys and the Earth make up the system. Okay? So right now the momentum is 0. I have the keys in my hand. As soon as I open my hand, the keys are moving down. The keys have momentum up, or have momentum down. I can get it right. Just running into the wall, scrambled my brain. Right? So right now the total momentum is 0. I open up my hand, the momentum of the keys is downwards. The total momentum, remember, must be 0. The ground rose up to meet it. The Earth actually moves up. Okay? Again, you'll never be able to measure it. Okay? But when I open up my hands and drop it, the Earth suddenly started to move up. And when I caught it, the Earth suddenly stopped moving. Okay? If I keep doing that, does that mean the Earth is going to keep coming up? All right? But it is true. If you take your keys, just open up your hand, the Earth will rise up. Okay? Just conserve the momentum. Now, if you just look at, me running into the wall, what we usually do is concentrate on the object that's moving. We don't consider the Earth as moving, right? It's too massive. I run into the wall, we see that my momentum is not conserved. I'm running into the wall, I bounce back, my momentum is not conserved. Why? Because the Earth pushed on me in that direction. Okay? I ran into the wall, I pushed on the wall essentially. I ran into it, I pushed on the wall pushed me back. So my momentum changed because the Earth pushed me in that direction. Okay? Why did the Earth's momentum change? Because I pushed on the Earth in that direction. Okay? When I release, I have the keys here. What forces are acting on the keys? Gravity is pulling down. My hands are pushing up. When I release my hand, gravity is acting on the keys. Okay? Remember, the Earth is pulling on the keys, but because of the gravitational force, the idea behind the gravitational force, the keys are also pulling up on the Earth. Okay? So that force exerted on the Earth by the keys is enough to make the Earth rise.